Hello, everyone. My name is Casey Wood, and this is my research on species abundance and occupancy of niche space. Now, some of you might be thinking, niche space? What's niche space? Well, I would like to tell you all about that, and I'm sure this deer would appreciate too. So, niche space is the physical space in which a species occupies. And this space includes things such as temperature and precipitation, seasonality and conditions of abiotic and biotic conditions, as well as food resources, and species interactions between species of their own and different species. Climate change is greatly having an effect on habitats all across the globe, and animals are having to adapt quickly or die off. But for now, what are animals doing? Are they moving? Where are they moving to? So, based on their niche space, we're going to be studying niche distance abundance relationships. So basically, where are these animals going to? Are they going to the core? Is that where they're most abundant? Or are they more abundant in their outer edges of their niche? So our question was, do they reach the highest abundance and occupancy at the center of their niche space? And I hypothesized that mammals are more abundant and have higher occupancy rates at the center of the niche space. So what we did, we set up various camera traps in Schenck and Umstead Forest, as well as using camera trap data from all over the country. After we collected our camera trap data, we chose 10 mammal species that are well represented in the camera trap data and had relatively large geographical distributions. This include coyotes, American black bears, bobcats, and Virginia possums. Then we used Tableau to configure and construct array level occupancy and abundance, comparing average occupancy, abundance within core versus periphery areas of climate niche. So starting off, we have the data for the American black bear. As you can see here, we have precipitation in the x-axis and temperature in the y-axis. These larger circles represent greater abundance, whereas these smaller circles reflect 0 to little abundance. And as it shows, it appears that there's a lot of abundance in the core versus the outer edges. And based on the graphs that I configured, it demonstrates that these bears do indeed have higher abundance in their core space versus their periphery. Now, let's move on to the bobcat. This data shows that bobcats are very abundant all over their niche space. They're not necessarily most abundant in the core, not necessarily most abundant in the edges. They're abundant almost anywhere in their niche space. And further data through this graph demonstrates this to be the case. There's no statistical significance to demonstrate that bobcats are more abundant in their peripheral or core. And the thing is that most of them weren't. Most of them weren't abundant in their core or periphery. They were just abundant everywhere, except for the American black bear. Why? Why the American black bear? Well, it could be some interesting new research. Why is it the American black bear chose this? I predict that it's because there was a greater amount of resources typically in the core of a niche space, and being that the American black bear is much larger than any of the other mammal species we chose, that could show that these large animals need to be in their core to get these necessary resources to survive. I would like to thank my group mates, Kelly Prey, Elena Savage, Ariane Trotter, Lucy Cone, and I would also like to thank Dr. Roland Kays and Alexa Murray. Thank you.